So here is the approach variable gradient method which we talked about in the last lecture. The approach is to choose a negative definite v dot and from that find v. We know that derivative of v with respect to time is the derivative of this v with respect to x, and then derivative of x with respect to time, and x dot is f of x. The derivative of v with respect to a vector is another vector which we named as g transpose of x, and this g transpose of x is equal to partial v over partial x, and therefore from partial v over partial x equal to g transposed, we can find v of x by integrating this g transposed and integration from 0 to x. Now this g transpose is a vector, this is a vector, x is a vector. How to perform this integration? This can be written in expanded form, that is this product is g1 multiplied by dy1 plus g2 multiplied by dy2 and up to gn dyn, which is written over here. How to integrate it? This is integrated in this way. For the first entry g1, you integrate it with respect to first argument dy1 and integration from 0 to x1, and for the second element you integrate it with respect to second argument and so on up to the nth argument. Since this g transpose is gradient of a scalar, always satisfies this property. So this must satisfy this property. So approach is quite clear. Select v dot negative definite, and once we have negative definite, find v from this expression. This v dot must satisfy two properties, that is it must be negative definite, and this part, that is g transpose, must also satisfy these conditions. So it looks quite slightly difficult, however its application is also somehow not so simple, but we learned it with the help of some example. We have some nonlinear system, x1 dot is equal to. So first approach is to select v dot. In selection of v dot, we have no control on it. F of x is the dynamics of the system. We can only select g transposed. So how should we select g transposed of x? Generally we select it in this way. In most of the cases it works. That is gi of x is selected in this way: aij of x into xj summation from j equal to 1 to n. The ith component of this vector is generally selected in this way. This is not a requirement, but generally it can be selected in this way. Over here we take g of x equal to here g1 of x. g1 of x, how to select it in this particular case? a11 of x, here x is vector, into x1 plus a12 of x into x2. This is g1. What should be g2? a21 of x, x1 plus a22 of x into x2. This is not requirement. However, if you take more general form of g, more will be the chances to reach at some conclusion. If you take less general g, then that will create difficulties. So this selected g must satisfy this condition, that is partial g. What is this condition for this particular case? the partial derivative of g1 with respect to x2 must be equal to the same as its derivative of g2 with respect to x1. How to write this condition for this particular case? The partial derivative of g with respect to x1. What is its partial derivative with respect to x1? Right. So with respect to x2, we are computing its derivative with respect to x2. 0. Why 0? This is function of x, so it contains x2 as well. So partial a11 over partial x2, right, into x1. It is the partial derivative of this with respect to x2, and then plus, how to take its derivative with respect to x2? Product rule. First function into derivative of second. First function into derivative of second, which is 1, and then second function into derivative of first. This is derivative of g1 with respect to x2. What is the derivative of g2 with respect to x1? For appropriate selection of g, this condition must be satisfied, which is rewritten over here. So how can we satisfy this condition? These are any functions, so you have to select a11, a12, a21, a22 such that this condition is satisfied. This is the requirement on G. So how to do that? Simpler is always easier. However, we have less freedom if we have simple situations. So let's first take the simplest situation and see whether it works or not. So if we take a12 equal to 0, a12 equal to 0, a21 equal to 0, then what do we have? We have selected a12 equal to 0, so this term is 0, a21 equal to 0, so this term is equal to 0, and then a11 is taken equal to 1, and its derivative with respect to x, this will also be equal to 0, and a22 is also taken equal to 1, so this term is also equal to 0. a21 and a12, these are selected equal to 0. So that satisfies our requirement, 0 equal to 0, right? That is, we have selected g equal to what? G of x equal to a11 equal to 1 in x1, a12 0, so a21 0, a22 is this thing. We have selected the simplest possibility. If it will not work, we shall move on to more complex situations. We have satisfied this requirement. All the terms are 0. This is also 0. This is also 0 because its a12 has been selected equal to 0. This is 0 because derivative of one constant with respect to x1 is 0. So 0 equal to 0 is achieved. So what about v dot? Is it negative definite for the selection of g? So what is v dot of x? V dot is equal to g transposed. G transposed is x1 x2 into f of x, which is minus 2x1 minus 2x2 plus 2x1 x2 squared. So what do we get? This multiplied by this is minus 2x1 squared minus 2x2 squared plus 2 x1 x2 cube. I think here is so this is the same as minus 2 x1 square minus if I take 2x2 square common, so we get 1 minus here 2 is taken common, x1 x2. Is it correct? So what about definiteness of V dot? Locally negative definite. Locally, when 1 minus x1 x2 is greater than 0, that is x1 x2, this product is less than 1, then this function is negative definite. So with this particular choice of G, we shall only be able to reach at local stability of the equilibrium point. Equilibrium point for this system is at origin. Once we have determined G, then we find this V by this way. So what is V of x? V of x is integration from 0 to here we apply this thing 0 to x1 and g1 of y1 with all arguments, other arguments set equal to 0. How to what should be here then? What is g1? G1 is this first component x1. So instead of x1 we write the dummy variable y1 and its integration with respect to y1 integrated from 0 to x1 plus here is the second term here integration from 0 to x2 and what is g2? x2. So we write it the dummy variable with respect to y2. So what is integration of this one with respect to y1? y1 square by 2, and if we substitute the limit, it equals to x1 square by 2. And what is the second integration of second term? x2 square by 2. So we selected a negative definite V dot and reached at a positive definite V. What is conclusion about stability of the equilibrium point? Equilibrium point is this was strictly negative definite, so equilibrium point is asymptotically stable. However, this asymptotic stability is local in the region defined by this expression. So the procedure is simple. However, you have to utilize your intuitive knowledge in throughout the procedure. That is how to select G such that V dot will become negative definite and V will become positive definite. The selection of V dot, only you have to select G of x. In general form of G of x is this one. It can be chosen less general, but less general means you will have less freedom and therefore less possibility of reaching to some final conclusion. Yes, there is a question.
Semi-negative definite.
Semi-negative definite, then we would say that the equilibrium point is stable.
Yes.
So हमारे पास जो Lyapunov function है वो हमेशा positive definite है.
It should come out to be positive definite. If it is not positive definite, if for example you have taken this one and finally it does not come out to be a positive definite function, then you have to change this selection. You have to change it. So remember that here this was not the only choice. Maybe you could also, this choice can also work. So this is not the only choice. This is another choice, and let's see whether this equality is satisfied for that particular choice or not. So what do we get over here? Partial A11 we have taken it to be equal to 1. So this term is 0. What about this term? What do we get over here? So for that particular case, A12 of x is x2 square, and A12 its partial derivative with respect to x2. What do we get? 2x2, and then this x2 2x2 square. This is the left hand side. Right hand side, A21 of x, what is that? 3x2 square, and then A21 its derivative with respect to x1 is 0, and what about this term? A22 is 1. So this equality is still satisfied for this choice as well, and then you will work out, check the definiteness of this thing, right? You will substitute, that is, you have selected this g here with this choice, g of x. What is g of x that you have selected? A12 A11 is selected to be equal to 1, so x1. A12 is selected x2, so here is, what do we get? x2 q, and A21 is 3x1 x2 square, and then A22 is 1, so x2. So this is g of x that you have selected. And next, what you will check, from this g of x, you will find v dot of x by this expression, g transpose of x into f of x, and if it is negative definite, then you will find v of x, and if it comes out to be positive definite, then that will determine the stability. So, any question up to this point? Let's take one more example. We have this system, and we want to determine the stability of equilibrium point, and we want to apply this approach to determine the Lyapunov function. For that purpose, a g of x can be selected, and this g of x works in many cases. So let's take a similar g of x. That is, we have then this g of x must satisfy this condition. That is, the partial derivative of g1 with respect to x2, that must be equal to the partial derivative of g2 with respect to x1. So this condition implies that here, for simplicity, we have taken this A11. Let me rewrite it to clarify the things. A11 is function of x1 only, and A12 is function of x2 only, A21 x1, A22 x2. So it is, this selection is less general than this one. More general would have been when A11 is function of both x1 and x2. Less general means less freedom, however simple. More general means more freedom. So we have lost some freedom, but it will be easier to handle. So its partial derivative with respect to x2 of this term is 0. Its partial derivative with respect to x2 comes out to be this one. Similarly, the partial derivative of this with respect to x1 is written over here. For appropriate selection of g, this must be satisfied. So what is choice? How can you proceed.
सर क्राइटेरिया
Sorry?
कोई क्राइटेरिया है A11 equal
No criteria. The only requirement is this one. Rest are intuitive things. You have to utilize your intuitive knowledge. That is how to select these things so that V dot will come out to be negative definite and V will come out to be positive definite. You have to utilize intuitive knowledge, and this will be different for different systems. This intuition, this is the difficulty in this approach. The advantage is that it is more general, applicable to more systems compared to the other two approaches that we have learned. Difficulty is that the procedure is not systematic. For each case, we have to use different intuition to determine which will be suitable. So that is one possibility. A12 and A21, let's take them to be equal, and then these A12 are also constant. A12 and A21 are constant. If these are constant and equal, then this derivative will be 0, this derivative will be 0, A12 will be equal to A21. So constant and equal. So we have selected them to be constant, A11 x1 plus A12 x2, and here is also A12 x1 plus A22 x2 multiplied by f of x. What is f of x? This right hand side. Clear? So if you find this product, and finally you will come up with this expression. Simply what we have done is, to satisfy this condition, we have selected A12 to be equal to A21 and taken them to be constant. This was from this requirement. To simplify our things at the cost of freedom that we had, we have also taken A11 and A22 to be constants. And then we have simply substituted, find this product G transpose F to reach at this expression. So what is intuition, what is the knowledge that we have over here? For this term, we can talk about its definiteness. For this term, we can also talk about its definiteness. This term is also, we can see the definiteness, but these are the terms which are creating problem for us. This one, and this one. These terms are problematic because we want to select a negative definite V dot, and these terms definiteness cannot be determined. So how to get rid of these terms? A12, A21 equal to 0. This term we want to get rid of it, and this term, and then we have this thing, V dot of x. Again, here you had different choices. Either you substitute A11 also equal to 0. Then what would be the conclusion? If I had taken A11 to be equal to 0, then what would have been the situation? This term would be eliminated, and we would have negative semi-definite V dot, and then we would have reached at the conclusion of simple stability. However, if we had put this to be equal to 0, A11, A21 is already taken to be 0, so x1 will be disappeared. So if x1 disappears, then V of x will not be a function of x1. That is, that will not be a appropriate Lyapunov candidate function. So we have lost the global condition, but at least we reached to certain conclusion. So we have this selection. With this selection, we have local negative definiteness of this function, and then g of x 1. So g of x is this one, and we have already computed v of x corresponding to this g of x, which was, and hence we are able to talk about stability of the equilibrium point. So here we have taken a11 not equal to 0. What is disadvantage of that? What is disadvantage of that?
Local.
We can only talk about local stability. What is advantage of that? What is advantage of that? We can reach at the conclusion of asymptotic stability. If we take this to be equal to 0, then what conclusion we can reach to? Global but simple stability, right? Not asymptotic. Why not asymptotic?
Negative sign.
V dot would be negative semi-definite. If you take this a11 to be equal to 0, then what will be v dot? V dot of x, that would be minus a22 x2 square. Then what conclusion we can reach to? Simple stability, not asymptotic stability. Okay? So you have to look for both pros and cons. However, this is not a big problem. The problem is over here. If we select a11 to be equal to 0, then what would be g of x? What would be g of x? First row is 0, and second row with all these selections is x2. And then based on this g, we shall finally find v of x, which will come out to be some constant plus x2 squared by 2. This is not appropriate choice for a Lyapunov function. Why not appropriate? This is not positive definite. This is not positive definite. What is definition of positive definite? Even if the one were not there, still v of 0 is equal to 0. However, v of x is not greater than 0. This is not greater than 0 for all x greater than 0. This is not the case, right? For whether I must write for x not equal to 0. It must be. So this a11 cannot be selected to be equal to 0.